Show that the relative velocity of approach of two particles masses m1 and m2 at infinite distances is this much, root of 2g by x m1 plus m2. So now I have to prove the relative velocity of approach of those two particles is this much. You must believe initially they are at infinite distances. So that means initially I am not able to show here. I am simply saying from infinity I am bringing one particle, this one, okay, and this particle is m, otherwise m1, and one more particle I am bringing, and this particle is m2. It is also taken from infinity, right, from infinity. At some instant their distance of separation, what you are seeing in accordance with the picture, say it is x, okay. At some instance the distance between those two particles is x. At that moment the two particles will have equal and opposite forces, say it is F. Definitely the two forces are in opposite directions but with equal magnitudes. From law of gravitation, what we can write, we can simply write either of these forces having the magnitude F is equals, right, F is equals G into m1 m2 divided by x square. This is the gravitational force on either of the particles. Be careful about their directions. At that moment the acceleration of this first particle, this one, is a1 in this direction, and a2, that is acceleration of this particle, is in this direction. Considering these things in mind, now we can write a1, the acceleration of the first particle, only the magnitude, which is f1, otherwise f divided by m1, okay. So f divided by m1, that means a1 is equal to, if you put this value of f here, definitely we may get g m2 divided by x square. Similarly, what I can put a2 is equals f divided by m2, but this is in opposite direction, so I can now put a negative sign here in order to calculate the relative acceleration, okay. So for that I simply make use minus, it is a g m1 divided by this is m2, that means it's x square. So considering all these things in mind, now the relative velocity, right, relative velocity of these two particles, the relative acceleration of these two particles is ar, which is equals, okay. So I am finding the first with respect to second, that is a1 minus a2, because those two particles are approaching, so we have to consider a negative sign, okay. So further a1 is this much, which is g m2 divided by x square. Here is minus and one more minus, so it becomes plus, right. It is g m1 divided by x square. When you solve this one, I get ar is equals, it is g inside bracket, it is m1 plus m2 divided by x square. So this is a relative acceleration of the two particles, right. Further, what I can write, if, okay, if Vr is the relative velocity of approach, relative velocity of approach, then in place of AR we can write dVr by dt. This is what I can write, dVr by dt. And further, I simply make some mathematical replacements, that is dVr by dr or dx into dx by dt. Here x stands for the instantaneous distance between the two particles. But one thing you must know, dx by dt is minus Vr, because x is instantaneous distance, v is the relative velocity of approach. As x decreases, v increases. That is the use of this negative sign in the equation. So now I am doing further. I simply use this notation here. Therefore, AR is equals, what I can put here in place of dx by dt, it is minus Vr into this much, it is dVr divided by dx. Make the cross multiplication. Now I got, it is minus Vr dVr is equals AR into dx. Right. Now make the substitutions for these terms. What is Vr? Let me keep that Vr as it is, into dVr. And what is AR? AR is this much, which is g into, in the bracket it is m1 plus m2, right, divided by x square into dx. In order to find the final answer, now integrate this equation, right, integrate this equation, this expression on both sides, that means integration of minus Vr dVr is equals integration of g, inside bracket it is m1 plus m2 divided by x square into dx. The result of integration is here, that is minus Vr square divided by 2, right, that is equal to what I can write here, it is g, in the bracket it is m1 plus m2 divided by minus x, right, this much I got. Now the negative sign on both sides get cancelled. What are the things which are left? Vr square is equals to g m1 plus m2 divided by x. Therefore, finally I can write Vr is equals, it is root of 2g and inside bracket it is m1 plus m2 divided by x. This is the result that shows the relative velocity of approach between the two particles only due to the gravitation. Okay, is the velocity of approach only due to gravitation. This is the result of today's question.